Okay, so here's the end view. This is just picture the end of the wire, current's into the board, right? Because I said current is into the board. Okay? At an early age, I was confused about whether you do a current into the board with something like this or something like this. Okay? So I'll never get it straight. It's totally lost to me. I can see it both ways. The arrow goes in and it makes a hole, but on the other side it spreads the paper out, right? But it might be the opposite of that for some obscure reason that I will never fathom, although I recognize it when I see it. So, but you know, a little mental glitch, mental inability there, something is wrong. But it's just because I didn't see it right the first time I saw it that I've always been confused about it. I've always got to check myself when I see those symbols. So I'm not using them. I'm just saying it's into the board. Now, okay, if the current is into the board, then your x-axis is this way, and if your y-axis is this way, then what's the direction of your z-axis? Yeah. Well, your z-axis is x cross y, right?
Yeah.
So the z-axis is not this way
No.
because that's where the x-axis is.
Yeah, if X is this way,
Yeah,
Y.
implicitly, we've got, it's been explicit, but you know, maybe implicit here. The x-axis is
Yeah, so it's gotta
along
come
the
this
line,
way.
and if the line is into the board, then the x-axis is into the board.
Yeah, so these
And you
come
cross
this
the
way.
x-axis to the y-axis to get the z-axis. Which has a lot to do with the fact that I cross J is K. Okay?
Yeah.
So the z-axis would be x cross y. There's your z-axis, right?
Yeah.
But then, of course, that means at the point, the distance A, okay, that the field
X cross Y into Z. X cross Y.
is in the K direction, which is in the Z direction, right? So it's like
You got X cross
this.
Y is to Z.
Now, of course, if you drew the same picture with the y-axis here, then at distance A, the field would be here, right? And if you keep rotating this, I'll draw one more, you can visualize the rest of them. At distance A, well, the field's got to be perpendicular to the y-axis, right? And where the y-axis is totally arbitrary. You know, not even in Newtonian physics did we declare that there's a universal y-axis that applies to the entire known and maybe unknown universe, right? Okay, well, what does this imply? It implies that your magnetic field, whatever segment you want to make here, has to be perpendicular to that segment, right? So I'm just drawing little segments of different y-axes as they could be drawn, and we see that these things are all perpendicular, all tangent to a circle of radius A, right?
Yes.
This is why the field surrounds the wire the way it does. Now you can verify that. Take a compass and a piece of wire and just do it, okay? That's actually a little difficult with a compass because if you turn the compass like this, well, gravity gets in the way. But anyhow, you get the idea.